Okay, so concept number 2. This thing over here, let's make it the number of you that there are. Say I say to you, you are running this race, and I want to know the number of ways that 3 out of 8 of you can be arranged in first, second, and third. So I'm only interested in first, second, and third, and I'm saying from 8 people, okay, arrange 3. Okay, so what I want is I want first place, second place, and third place, and I want to know the number of different ways that you can get that done, right? So the way this is written is it's written like this. This is probably the easiest way. From 8, arrange 3, right? You can also write it like this. From 8, arrange 3. There's no dodging the notation. Please just get used to it and start using it because things are going to go badly otherwise, right? The formula is this. If we're going to choose some to arrange from, it's going to be n factorial at the top, and then it's going to be n minus r factorial at the bottom. I want you to understand why, so I'll explain this to you in a minute, right? I wouldn't advise you to use the formula. I'd advise you to use common sense. You don't need to memorize it. You can just think. But what this is saying for this particular example is that we'll have 8 factorial ways that we can arrange everybody, right? And then at the bottom here, we want 3, so that's going to be 8 minus 3. So r is the number we want, okay? That's what we want. And we are going to have 8 factorial over 5 factorial. If you had 8 factorial over 5 factorial, what would that equal in multiplication? Don't give me the final number, the method. What would be left? I'm cancelling 5 factorial into 8 factorial. What's left?
8 times 7 times
8 times 7 times 6. Do you agree? What 8 factorial is, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So I'm saying that you're going to get the right answer if we cancel this with 5 times 4 times 3 times 2 times 1. So what I'm doing is I'm effectively removing these ones, right? I'm removing that. This should be logical. Why? Think about it this way. So I'm interested in who comes first. Who comes first? We have 8 different options. So there's 8 of you. I'm going to give you each a number because putting your name down is going to be awkward, right? So there's 8 of you who can come first, right? Then from those 8 people, there's going to be 7 branches in each one of who can come second. Do you agree? So either the person 2 or person 3 or person 4 or person 5 or person 6 or person 7 or person 8, right? There'll be 7 branches there, there'll be 7 branches there, there'll be 7 branches there. So that's 8 branches times 7 branches, right? So we've got 8 times 7. And then the third person, there are now only 6 options. So if we've got 3 already and we've got 1, then we're going to have, 2, 4, 5, etc. There'll be another 6 options. Do you agree? So at each one of these branches, there'll be 6 options. So basically that is what you're doing, is you're saying we only care about how we're arranging the first 3 people. There are 8 choices for first. Each of those 8 choices has 7 choices for second. So that's going to be 56 choices by the time we've got first and second. And then each one of those has got another 6 choices. So 8 times 7 times 6. So what you're effectively doing is you're removing all the people that you don't care about arranging. So you are removing these arrangements. And that's how I do this. I don't use the formula at all. I think 8, I want to arrange 3. Therefore, I want to remove 5 sets of arrangements. So I remove 5, right? So 0 factorial is equal to 1. This is because if from 8 you're going to arrange 8, then that means you're arranging all 8, right? So the obvious answer is 8 times 7 times 6, great big number, right? And if you fill in the formula, at the top you're going to have the 8. At the bottom you're going to have 8 minus r. 8 is how many we care about. We care about all 8. So it will be 8 minus 8. We're removing none. We're keeping all the arrangements, right? And as a result, we end up with 8 factorial arrangements. So 0 factorial must be equal to 1 or it wouldn't make sense. Okay. So now you are going to do page 68 and then the homework that's on the board. So please do page 68 immediately. I'll go through it with you in a few seconds. So for A, they mean with replacement. So they do ask this question fairly often, not always, but it basically means it's like you have a giant bag And inside the bag, you've got lots of 1s and 2s and 3s and 4s and 5s. So it is possible to choose one more than once, right? So if you have replacement, you can choose one or the first time, or you can choose 2 or 3 or 4 or 5, right? Those are your choices for the first one. Your choices for the second one, you still have 1 because you've got an endless number of 1s to choose from. So you could choose any one of those numbers for the second one. Do you agree? And then for the third one, you would still have 5 options because you've got an endless number of 1s, right? So you would have 5 options the first time, 5 options the second time, 5 options the third time, 5 options the fourth time, and 5 options the fifth time, right?
Does that mean that they don't get taken out of the bag?
Yes. Remember, with replacement means we put them back. So what is 5 to the 5? Louder, 3,000?
3,125.
Still didn't hear because you both spoke at once.
3,125.
Thank you very much. Okay, so that's the first question done. So when you have an even number, what does the number have to end in? 4 or 2 in this case, right? It has to be divisible by 2. So we have 2 ends. We have ends with 2, and we have ends with 4, right? So we've got 2 ends. And now they say we choose 4 numbers. So we need to choose another 3, right? So we've got, for this one, we've got 1, 3, 4, and 5. And we need to choose 3 of those 4. Do you agree? Then we'll have a 4-digit number that ends in 2. Okay? The other one, it ends in 4. So we have 1, 3, 2, and 5 to choose from, right? And again, we want to choose 3 numbers because it's going to end in 2, it's going to end in 4, and we need 4 numbers in total, so we need to choose 3. Do you agree? And obviously you've got 2 options here. So this one, you'll notice that if you have 4 factorial over the opposite of that one, 1 factorial, that's just 4 factorial, right? So that's just 4 factorial, and 4 factorial is 24, right? So there's 24 numbers that you can get that end in 2. And there are 24 numbers that you can get that end in 4. So you can get 48 different choices.
I thought they knew when you add all the numbers together.
No. Remember, they're just arranging. They can ask you that sort of thing, but it will be very obvious. Okay. And then please try the same for E. It says a number starts and ends with an odd number. If I were you, I would write down what that would look like. So you have 6 options.